This section of the slideshow, we'll take a look at roof construction. First of all, we'll take a look at step-by-step construction of a simple barrel vault roof, and then we'll move on to the more complicated roof involved in this building in Colorado. Here's a simple barrel vault roof for a low-income project. The footprint for this simple building is 4 by 9 meters with lofts on both ends. The total price for this building was $7,500. The roof was approximately 1/3 of this total. This roof should give us an idea of the basic steps before we get into the more complicated roof which we built in Colorado. This building is a Casita Linda project, and we'll talk more about them later. The barrel vault is formed with 6x6x6 welded wire driveway mesh, which is held up with 1x2s and 2x4s. All this that you see in the picture is formwork and comes out and gets reused. We're looking almost straight up in this photo. The plaster lath is in place. Note the overlap. We're starting to apply the shell on top of the plaster lath. Above the whole business, note the walking plank running down the center of the photo. This is so you can work off the top. Here's another photo of applying the shell. We usually trowel the lightweight concrete out of buckets, and what we talk about is applying it like a snowfall so that it just sets on the mesh. If more than 10% is falling through, either your mix is too wet or you're pressing down too much on the trowel. In this photo, we're working on the first half of the roof. We moved the formwork on this job, but on the next unit they're going to do the whole roof at once. It's a fairly small roof, only 4 meters by 9 meters. The red arrows are pointing at the edge of the plaster lath. That's as far out as we can run the shell at this point. The blue arrows point at 1x2 horizontal supports running between our 2x4 mother supports. The good news is all of this formwork can be reused 50 times. Only the plaster lath stays in. Here we're looking up at a seam. The left side has been poured. The right side has a new shell in place. The Starry Night look is okay on the shell side. The 6-inch driveway mesh comes out and is reused. Here we're pouring the roof on top of the shell. On the right side of the photo, the roof has been poured, and on the left side of the photo, there's a new layer of driveway mesh in place on top of the shell. This side is now ready to pour. This driveway mesh stays in place. The red arrow is pointing to the walking plank, which allows us to access the top of the roof. The blue arrow points to a wooden T extending up through the roof, so there's a hole at the roof in the roof at this place. Here's a photo from the other side of the building. In this photo on the far left, we see a section that has been poured with 2 inches of hard pumice that grabs the reinforcing mesh. Moving to the right in the photo, we see that under this reinforcing layer is a 4-inch layer of lightweight pumice that serves as an insulation layer. And on the far right of the photo, we see just the 3/4 inch shell. We notice in the foreground that we built up the sides of the roof with pumice blocks on this roof, which was kind of a new idea, and it worked well. We'll talk more about this building and this roof later in the slideshow. Let's follow these basic steps on a more complicated roof, our example roof in Colorado. Here's the start of the Colorado roof under construction. The first thing we need to figure out is how we're going to build the roof. Each roof is a little bit different. One thing we do know is that we're going to build half the roof at once and then move the formwork and then build the other half of the roof. The strategy we came up with on this building was to pour the arches first, indicated by the red arrow, and then between the arch beams fill in the vaulted space, starting at the central column and coming up from the exterior walls as indicated by the blue arrows. Here's our roof building sequence. First we do the rib beams, which are numbered in the drawing in black, and then we fill in the roof membrane sections between these ribs shown in red. Then we move all of the formwork over the other side and do the other side of the building. Here's a cross section of the rib beam. Some of these ribs only had one piece of 1/2 inch rebar inside for a structural bone. The idea with these beams is to, number one, tie the center column to the perimeter columns with a reinforced arch, and you end up with a square donut. And the second idea is to tie the ribs to the exterior buttresses and tie them together over the central column in a catenary shape. This is the swarming gringo photo. This is where we're starting to do the roof formwork over the first corner. All of the rebar you see is formwork and comes out and is reused in the next vault. The red arrow is pointing to the arch beam that has already been poured. Here's some big mountains in the background of this shot. This is a shot from outside of the building. The trick here is to cut the driveway mesh into smaller pieces, 3 by 4 feet for example, or 2 by 6 foot sections, and then cut them further so they fit in between the rebar formwork. Note the thickened door and window frames we formed with the pumice block. Here we're working out from the central column, tying small pieces of driveway mesh to the 3/8 rebar, which is forming the ribs. In order to get good relief here and a good rib look, it's important that the ribs must be deep and well defined. The red arrows point to the 3/8 inch rebar that indicates the high points in the vaulted sections between the ribs. The yellow arrows point to rebar indicating the low points on the ribs. It is important to start off with good definition between the ribs, since you tend to lose it with each additional coat of plaster. Here are some tools and techniques. To make the flat 6/6 10/10 welded wire mesh into more of a roundy shape, notice at the top of the photo it has been cut and then wired together. Twisting it with pliers also helps to generate a funnel shape. Plaster lath is cut with 10 snips and wired on using U's made from tie wire. Since the driveway mesh will be removed later, these U's are usually just bent over and not twisted much. The bent over sections of these U's, of course, want to be on the inside for later removal. Once again, the plaster lath stays in, the driveway mesh comes out. On the right, notice the nails with tails. These are used to attach the plaster lath and the driveway mesh formwork to the walls. In the center, we show bending 14 gauge galvanized to make it roundy for formwork for a tight inside corner. On the right, also notice a nail in the end of a 1x2. This is used to hold the mesh in place as it is wired up, and later to hold it in place while you put on the shell from above. Here we're throwing fairly small, for example 2 by 3 foot pieces of plaster lath on top of the driveway mesh formwork. The lath is then wired down using the U's. It works best to have one guy up on top and one guy underneath bending over the U's. Once again, the rebar paints the high and low places in the roof. In this photo we have the driveway mesh in place in the first corner. Guys on the inside and the outside of the formwork. At this point we're ready for the up guy to slap on small pieces of plaster lath and the lower guy to wire them down using U's. This is a detail of the inside corner. Plaster lath is nailed to the pumice blocks using nails with tails. Notice that wet paper bags have been stuffed into the lower end of this corner so that the shell doesn't run out the bottom. Here's another view of the inside corner. The red arrows point to areas where nails with tails hold mesh and plaster lath to the wall. The blue arrow points to a piece of 3/8" rebar that helps form the inside corner. Here we see some of the 3/4" shell has been placed on the first corner. The 1x2 sticks are now the right length. Some of them have been scabbed together and some of them have been cut so that we can reuse them several times as we move around the building. On the left hand side of the photo, note the way we do the door and window framing. This is a swarming Mexican photo. This is my crew in Mexico. In the upper part of the photo, Dolores is putting on the shell from the top while the rest of the crew tries to stay ahead of him, putting on driveway mesh and plaster lath. It looks like a pretty good scaffold setup here on this job. Here we're placing the shell on top of the plaster lath. Charlie likes to use a pool trowel to help dig the mud out of a bucket. The trick is to just barely touch the mud to enter the mesh without running through. Now, I'd say if 10% falls through when you start, that's okay, but you shouldn't have 5% falling through after you know what you're doing. This is looking almost straight up at Miguel placing the shell on a job in Mexico. The idea is to lightly press the mortar into the mesh. 90% coverage is okay, and the Starry Night look works just fine. This is a close-up of a fairly ugly spot on the inside surface of the roof. The 6/6 driveway mesh comes out, its formwork, and we end up with a great surface for attaching the plaster coat. Here we see 1x2s holding up the concrete roof. In the center, note the 4x4 that's used for the skylight formwork. Some roof sections in this photo have been poured, and some are just 3/4" shells at this point. As you can see, we didn't raise the south walls until we finished the north roof so that we could get the John Deere into the center of the building and place mud on the roof, the north side of the roof. Now let's talk a little bit about the bond beam. In this photo, the shell has been placed, but the roof hasn't been poured in this area. The red arrows show the double 1/2" rebar in place that will form the bond beam, and the blue arrow shows where we will connect to the catenary buttress. The red arrows in this photo indicate where we're going to have buttresses coming down to the ground. In this photo, you also notice the walking plank we have at the top that allows us to get around on the roof. Here's the horizontal bond beam ready to be poured. Notice that there's two pieces of 1/2" rebar, plaster lath for the outside of the form, and the roof shell for the inside of the form. We'll fill this void with 4,000 psi concrete. In this photo, the bond beam has been poured. This is on the second half of the building. This is how the walking plank ended up looking on the second half of the building. Here's a good shot taken from the center column. Here we're filling the valleys on the rib beams. Typically we put in 2 1/2" rebars with driveway mesh extending up on both sides, and then shovel the hard concrete into the valley formed by shells on both sides of the ridge beams. Here's another good shot. The red arrows are pointing at the rib beams that have been poured. The blue arrows are pointing at the standoffs we use to hold the driveway mesh up, so that the vault on the right has half the shell placed and is ready for more shell, and on the left we see where we're putting the driveway mesh and the standoffs on. This section is ready for the structural pour. Here's the reinforcing mesh in place. The trick is to tie it down fairly tightly and then pull it up to put the standoffs underneath and give you space of concrete underneath. This is now ready for a 2.5 inch pour of 3000 psi. On the lower left, note that we have mesh sticking out from the rib beam that's poured, and the mesh that goes out over the field is tied to this mesh. Here we're putting mesh on top of the shell, getting ready for the structural pour, twisting the driveway mesh so it lays flat. Inexact is okay, just as long as you get an inch of concrete under the mesh and an inch of concrete on top of the mesh. Here we're placing the structural layer using the tractor. Charlie is slopping on neat cement slurry on the shell before placing the mud. This acts as a good bonding agent, and we use gallons of it. Shovel it on and bang it down with a trowel. The layer is so thin that it is hard to vibrate it with a traditional vibrator. The tractor driver, Charlie, is up on the roof with the trowel, so as we can see, this step goes fairly slowly. At this point, the north half of the roof is done, and it's time for some more walls on the south side and time to remove and reuse the formwork. Here's the roof formwork. I think it's something like 40 1x2 total. These were 10 and 12 foot spruce. You need fewer sticks for the second side because the formwork is already pre-bent and goes into place easier. So here we're starting on the south walls. The north roof is done. Note the arches we make with the 3/8 rebar for the window openings. Here we're starting on the south half of the roof. We've moved the rebar and driveway mesh formwork and are attaching plaster lath. As you can see, very few sticks are needed to hold everything in place. On this side we'll do the shell first and then pour the rib beams in between the shells. I complicated the design as usual, so we didn't move everything exactly, but we had lots of pre-bent pieces that fit most anywhere, and this half was much quicker to form. The arrow points to a 2x4 brace used under the rib beams. At the top of the photo, note the bond beam running on top of the window frame. This is half the shell on the second half of the roof. Note the good scaffold setup underneath the roof formwork. In the background in this photo we see the existing straw bale house and the teepee guest house. And in this picture we're placing the structural layer on the second half of the roof. This section of the roof is done for now, and we're wetting it down before tarping it up. We cured all of the structural roof sections for at least 2 weeks. The shell sections, we didn't worry about curing them, we just tried to keep them wet for 3 or 4 days. This drawing is a typical roof section, and we are still working on insulating the roof, and we'll cover that later in the slideshow.